Hi, welcome to Antarctica Live. I'm Dion, I'm your host today, and we are joined today by Ted. Hi, Ted.
Hi.
Hi, Ted, could you explain what your role is and what you're working on right now?
Yeah, I am a senior research scientist at the University of Colorado in Boulder. I'm an Antarctic expert glaciologist. I've been to Antarctica 22 times, all over the continent in many different places. And for the past 5 years, we've been working on one of the largest glaciers in Antarctica and one of the ones that has the biggest threat for sea level rise for the coastlines of the world. It's called Thwaites Glacier.
Oh, that's amazing. Ted, you've been to Antarctica 22 times. You must have seen some things.
Yeah, yes, uh, all different parts of Antarctica. Antarctica, of course, is the continent at the southern end of the world, and it's actually got different sections. Part of it sort of sticks up like a finger towards South America, and we call that the Antarctic Peninsula. And then there's the part that's in the Western Hemisphere. Mostly it's south of the Pacific Ocean, and we call that West Antarctica. That's where Thwaites Glacier is. And then there's a big area about the size of Australia, but with 2 miles of ice piled onto it. That's called East Antarctica. And I've been to all three of those areas over the last several years, studying how Antarctica is responding to climate change. And it's responding in many ways.
That's amazing. I believe you're part of something called the Tarzan Project. Could you explain a little bit about that?
Yes, one of the projects that we have studying the Antarctic, the Thwaites Glacier in Antarctica, is called TARSAN. That stands for Thwaites Amundsen Survey and Regional Network. Thwaites Amundsen Regional Network and Survey, sorry. And what that means is it's studying the coast of Thwaites. Thwaites borders a patch of the ocean called the Amundsen Sea. So Thwaites Amundsen Regional Survey, we're studying this region, and network, meaning that we've set up a bunch of instruments that record data year round, even after we've left, and they send the data back through satellite.
That's really interesting. Can you tell us why you're studying the Thwaites Glacier in particular? Why that?
Thwaites is a huge glacier. It's actually the widest glacier on Earth. It's over 70 miles wide, and it's flowing at a rate of about a mile per year into the ocean. And that speed is picking up about 2 kilometers per year into the ocean. The reason it's picking up is that the ocean is melting the front of Thwaites Glacier and causing it to flow out faster. And that's a problem because Thwaites actually holds enough ice to raise sea level by about 2 feet, about 60 centimeters, all by itself. But if Thwaites goes and it collapses, it will take a lot of the West Antarctic ice sheet with it. And that would represent about 2 meters or 6 feet of sea level rise, a really disastrous amount of sea level rise. Now, this process is very slow. It's going to take decades for it to begin, but over the next several decades, we're anticipating that if we don't turn around climate change, we're going to see a big increase in the amount of ice pouring into the ocean from Thwaites Glacier.
So your work sounds incredibly important. How did you get into your job role? What was your journey to become what you are
You
now?
know, when I was young, I really liked being in the outdoors. I really liked hiking around outside and engaging with the landscape. And then I got into school and was really interested in physics and astronomy and geology. And I got my degrees in geology. And I really didn't expect that I would become a glaciologist until I started working at NASA for a scientist who was studying Antarctica. And we went on a field expedition, the very first one that I went on a long time ago. And that was extraordinary. It was really a fantastic experience. It truly is like visiting another planet. First of all, it's beautiful. And it's also challenging because you have to suit up, if you will, get ready for working outside. You bring a lot of instruments with you, and they're needing to be operated, sometimes fixed in the field. You're really on your own in terms of thinking through problems and solving whatever issues come up, and continuing to think about how the world works, what makes the glacier go, what makes the glacier go faster. All of that was really exciting to me. I really liked it. And we started working further, mostly applying satellite data, but every other year or so visiting Antarctica, sometimes twice in 1 year.
So, on your many visits to Antarctica, what is the best thing you've seen? For a lot of people, they'll never get the opportunity to go there. So,
I've been awestruck so many times, it's hard to pick. The peninsula is absolutely spectacular. You know, it would be a national park in any country. The whole thing ought to be a World Heritage Park. It's beautiful. It looks like a continent struggling to emerge from an ice age. You really get a sense of how ice flows in the Antarctic Peninsula, because you can see the streaky lines of flow on the glaciers coming off of the landscape of the mountains. I was really struck by standing on the plate of ice that's in front of Thwaites Glacier, called the ice shelf, and looking back at the main continent. And there on the horizon, low on the horizon, you can actually see this glacier rising up, flowing straight at you, rising up in the distance and covered in crevasses. And when you realize that it goes from one side of the horizon to the other, and it's all moving towards you and cracked up with crevasses, it's really quite moving. You can tell that you're standing at a point on the Earth that is a potential threat to everyone because of this massive amount of ice that's headed towards the ocean and going faster and faster. I guess the other thing that really impressed me was, it's a little obscure, but there are some giant dune areas in East Antarctica that are sort of like the Sahara Desert, but made of snow and bitterly cold. And the surface there is very old. Parts of the surface have been sitting there with no snow gathering on them for 200 years. And when you realize all of that, it's pretty special, although it's a very harsh place to work in. It's dunes, so it's windy, and that means it's windy at minus 30 degrees, which is a tough situation for anybody.
wow, sounds absolutely incredible. I have some questions, if you don't mind me asking, that have been sent in.
Oh, please do.
The first question comes from Clarkstown South High. They asked, why do scientists study the unique and harsh environment of Antarctica?
They tell us about how the Earth works better than the areas that we're more familiar with. They tell us what the extreme conditions lead to in terms of processes that we're not familiar with, or just understanding how landscapes work under different conditions. Sometimes it's sort of the reverse of one of the tenets of geology. The present can be the key to the past, that the situations that we see in the coldest parts of Antarctica now would have been in process during the last ice age in places like North America and Scandinavia. So it's exciting to study those areas. It's an extreme version of what the Earth can do. It also gives you an insight into what happens on other planets, like Mars in particular. And so it's exciting to go there. If you like Earth science and hiking, like I do, then seeing the Earth behave in this unusual way, it's a lot of fun.
Amazing. Another question we've had comes from Kingsbridge International High School, and they ask, how do the dynamics and behavior of the Antarctic glaciers differ from glaciers in other parts of the world? And why is the difference significant for scientific research?
Well, first, I'd like to hire this student to work with me because that's a very sharp question. Mainly, glaciers in other parts of the world aren't as cold in the interior as they are in Antarctica. So you have much warmer and softer ice in most of the glaciers, like in the Alps, or what few glaciers are left in the Rocky Mountains. In Antarctica, the surface is cold and the interior is cold, but often the very bottom of the glacier is melting, not everywhere, but is melting. And that makes the glacier move much faster. So the difference between places that have water at the bottom and those that don't have a big impact on how the glacier flows and how susceptible it is to change. So that's a first cut of the differences, but we could talk some more if he's interested about other differences.
Oh, absolutely. Another question we've had from Portchester High. They ask, what are some of the biggest challenges you face as a researcher in Antarctica?
You know, I have to be honest that some days just finding the will to get up, get going, and not just exist out there, but make the instruments work and challenge to get extra data or take a further step away from, say, the camp and collect data at the far end of where you're working. That can be really tough when the weather is bad. We do take breaks, but a lot of folks, are really daunted by how grueling the schedule can be. I mean, you'll work, if the weather is good, you can work for 16 hours, 18 hours before sleeping, even more than 24 hours if you know you're going to take a break after that. But on top of doing this science work, for the kinds of teams that I'm on, typically 5 people, 8 people, 10 people, stuck in the middle of the ice sheet, hundreds of miles from anywhere, you're taking care of the camp at the same time. So you're making the generator work and you're cooking all the meals and you're dealing with making water from snow and taking care of the tents, being ready for a storm should it come. So I would say that the most challenging thing about it is, as I said, getting things to work right, getting good science, pushing yourself to find out a little bit more, even when the conditions aren't ideal.
And yet you've gone back 22 times. It sounds tough. Amazing, but tough.
You know, it's fun. It's a lot of fun. The folks that you're working with usually become some of your best friends. You're able to tell all these stories about experiences in a far off part of the world. It's exciting science because it's changing and it's relevant to what people talk about every day: climate change and sea level rise. So no, it's not bad. It's bad when you're there on some days. You asked what the most challenging was. You know, the best is when everything's working and the winds are light and it's calm and sunny and you can sit out afterwards and maybe even sip a beer or something like that at the end of the day and just think, you know, we got this going on. This is going to work. Or a soda. Yeah. It's a lot of fun. I really enjoy it. It's an amazing adventure, and you do it mostly with good friends.
Okay, the next question, and I love this question. What is the greatest discovery you have made?
Oh boy. Well, first of all, science is a collaborative effort and an effort that builds on everyone's work. So the greatest discovery I have made is still related to work that people had done previously. Some building blocks, some ideas that pertain to one glacier that were applied in a new way to another glacier. I was able to use pairs of satellites, satellite images, to track how a glacier flowed using a computer. So in particular, Landsat, or picture of the surface of the Earth, one taken 1 month and another one taken a few months later, shows the landscape that's not moving still in the same place, and the flowing ice has moved. And people had been tracking it by looking at the pictures and marking points that were the same but had moved a little bit, and managed to apply a program to do that automatically so that we could get thousands of points of motion from two images within a few hours, less than an hour now. In fact, it's on the order of 15 seconds now. That's gone a long, long ways. The other thing that I've worked on with colleagues that has had a lot of interest from the community, a lot of citations, a lot of referencing of this particular publication, was on how an ice shelf in the Antarctic Peninsula disintegrated due to climate warming. And some of the pictures from that study made the cover of the New York Times in April of 2002.
Oh, well, thank you so much today.
Oh, thank you very much for the chance to talk to you and to answer the questions of the students. That was great.
Now, don't forget, you can watch all of this week's live Q&As on demand. Thank you for watching.